Okay, so now what we're going to do is we're going to use molar volume as a conversion factor. Molar volume is 22.4 liters per mole, and this is at standard temperature and pressure. Now, we've not studied gas laws yet, so you don't have to worry about what standard temperature and pressure is, but for right now, all the information that I give you, we're going to do any gas right now at standard temperature and pressure, so you will not need to be concerned about that on this chapter. Later on, I'll explain when you do need to be concerned about that. So we're going to use this as a conversion factor. And just like before, remember how I told you that you can use your conversion factors and you can flip them? This can be 22.4 liters of gas per mole, or you can write it as 1 mole equals 22.4 liters. Again, this is only of a gas. This is not of a liquid. We would use density in that case. All right? Now, let's do an example problem. Let's suppose I have 1.39 moles of O2 gas at standard temperature and pressure, and I want to change that to liters of gas. All right, I want to find out how many liters of gas that many moles of gas is. All right. What I'm going to do is I'm going to say 39 moles of O2. I'm going to use my conversion factor of 22.4 liters per mole. Now, what do I want to cancel out? I want mole to cancel out, right? So here, I'm going to put mole on bottom, and I'm going to put 22.4 liters on top. Mole cancels out. I'm going to multiply that together, and 1.39 times 22.4, and that equals 31.1 liters of O2 at standard temperature and pressure. Okay, what we're going to do then is we're going to try to do number 6, all right? And so I hope this records right, I don't know. But we've got 589.4 grams of carbon dioxide. So that's not what I want. Actually, okay, there's 589.4 grams of carbon dioxide. Now we're going to, we're not going to right off use the 22.4, are we? We're going to use, and y'all tell me out loud, we're going to use what first? I have grams in the problem. We're going to use what first? The molar mass from the periodic table. All right, thank you. And so what I'm going to do is I'm going to look up the mass of CO2. I already know that. It happens to equal 44. All right, so I'm going to look at carbon dioxide on the periodic table, 44 grams in 1 mole of carbon dioxide. All right, grams of carbon dioxide cancel out. Okay, now I have moles, but the problem told me it wanted it in liters, right? So what I'm going to do is I'm going to now change my moles of carbon dioxide to liters of carbon dioxide by using 22.4 liters at standard temperature and pressure. All right, so now mathematically I'm going to take everything on top and multiply it together. So I'm going to say 589.4 times 22.4 equals, and that gives me a big number, divide that by 44, and that gives me 301, and because I can keep 4 significant digits, I'm going to leave that way. Now, and that's liters of CO2. Now, by the way, as far as significant digits goes, I want you to notice that I used the original problem for significant digits. I didn't use the numbers that I had supplied, because they can be counting numbers, or I could get as more specific. I just didn't. So I'm using this as my number to figure out significant digits. Since that has 4 significant digits, then this has 4 significant digits. All right. Remember also, just for those of you who like to do it in fewer steps, I could have done the same problem like this. 44 grams. I know it has to have grams because grams in the problem, so I know I have to use periodic table. I'm going to liters, 22.4 liters. Since the 44 grams per mole equals the same thing as this also equals moles, the 22.4 equals moles, I can use those in the same place, and I will get the same answer. So I do not mind which method you use. And of course you can inverse this. The whole key is letting your units tell you what to do and knowing what your conversion factors are.